National Park Association's Night Explorer series. We'll just start out with some of our usual reminders. If you're watching on Zoom, make sure you turn off your microphone, mute it, and stop your video feed so that you don't find yourself unintentionally on view for everybody who's watching. We'll use the chat on both the Zoom and Facebook Live to share any links and information with you. And we encourage you to tell us where you're viewing from, if this is your first time viewing, if you're a returning or a regular viewer. And those of you that are returning viewers know that the Voyageurs National Park Association is the nonprofit charitable partner of Voyageurs National Park. Some of the things we do are, for example, this Night Sky Explorer series in celebration of the dark skies we have here over Voyageurs. And hopefully in the near future, Voyageurs will be receiving the dark sky certification from the International Dark Sky Association. Other things that we do is we provide K through 12 youth educational series, provide funding for different projects in the park. And the way we're able to do that is from you, our viewers and members. So if you're interested in finding out more about Voyageurs National Park Association, you can go to voyageurs.org. And we have one of our awesome volunteers here today, Astro Bob King, who is retired from the Duluth News Tribune, where he was the photo editor. He has his own blog. You can see that on our screen, astrobob.areavoices.com. So please welcome Astro Bob.
Thank you very much, Jackie, and good to see everybody back. And for anyone who hasn't been here before and is new, we've had a beautiful summer here in our region with lots of clear nights. I certainly hope that you've had that too. You've had some opportunities to just go out, enjoy the moon. Like last night, we had a full moon. A couple nights before that, the moon was lined up with Jupiter and Saturn. Beautiful conjunction. There always seems to be something happening up there, which is the reason I'm here to kind of relate that to you and tell you about what's next. Before I go into that, I do want to remind you that occasionally you will hear the audio signal lag, so it'll stretch out for a moment, like my voice is made out of rubber, but it will snap back and you'll hear the regular audio. It'll come around in a few seconds, so pardon that problem. That's just an internet connection issue. I wanted to start today, though, astronomically, with it being a brand new month. I wanted to remind viewers to be sure to go to skymaps.com. There we go. Now you can see my ugly mug and the map, skymaps.com, and you can download a free map of the night sky. It shows the entire night sky. The dome overhead flattened into a circle, the outer part being the horizon, the center of the map being the overhead point. And on this side of the map, you're going to see a list of sky events. So it's very handy in case you want to know, well, what's going on tonight? Is there going to be a conjunction I want to see, or a bright asteroid, or maybe even a new comet? And that can be found at skymaps.com. Well, today we're going to talk about something that's happening 1 week basically from today. So today's August 4th. On August 11th and 12th, we're going to have a wonderful event that happens every single year without fail, and it has for many, many years. And that's the Perseid Meteor Shower, the annual Perseid Meteor Shower. So I'm going to jump right in and take you to some pictures that I have. All right, and we're just about there. We're going to have an encounter, as you can see, with the Perseids. This will happen. Of course, actually, the Perseids are active right now. They start in late July, and they last all the way till mid-late August, but they peak, and that's when you'll see the most Perseids in one particular night. They peak on the night of August 11th and 12th. And they are called Perseids because they appear to stream from one particular direction in the sky called the radiant. And the radiant is located in the constellation of Perseus, the hero. Now, Perseus is kind of this gangly, faint constellation. And you don't have to know the constellation to see the shower. But if you want to know about where the Perseid meteors stream from, is just below the W of Cassiopeia. Here's this sky chart that I made. Here's the W right here. I set the time for 10:30 p.m. August 11th, facing north. And if you face north at that time, once it's dark outside, you'll see the W hanging there in the northeastern sky. And just below it is the constellation of Perseus. Here he is right down here. And there's the spot called the radiant, where the meteors will appear to stream from across the sky. You see, I've made some meteors here for you, just in case you get cloudy skies. You can look at this map. No, just kidding. So we have these meteors. Notice that they all point back to the radiant. You can always tell a Perseid meteor from any other kinds of meteors because there's random ones too. These are very special, as we'll learn in just a moment. You can tell them apart because Perseids, if you follow their trails backwards, they will always point down towards the northeast W, towards the radiant. It's a very special spot in the sky. I'm going to learn more about it in just a moment. Peak night, August 11th, that's next Tuesday night now. August 11th, we will see from a dark sky without a moon to flood the sky with light, we will see up to 100 meteors per hour. That's kind of a theoretical, right? I have seen a lot of Perseid showers, and you may have too. Realistically, you see more like 60 an hour, which is not bad. I'll take 15 an hour. I love watching meteors fly through the sky. I like the feeling of just the anticipation. That's part of the pleasure of watching a meteor shower, thinking when and where's the next one coming from. So if I only see 5 or 10, that's good enough. But sometimes you can see bursts. You might see 2 or 3 almost at the same time. There's always surprises with any meteor shower. What the heck is a meteor anyway? Well, you hear about these other words that sound like the word meteor. So I think it'd be a good point right now to just define the 3 types of meteor words that there are. The first is a meteoroid. A meteoroid is actually a tiny fragment of comet or asteroid, a little rocky fragment primarily, that is still out in space. Okay, it has not entered the Earth's atmosphere, so it's just out there, dust in space, little crumbs. When it enters the atmosphere, when the Earth plows into it, then it heats up and it causes the air to glow. And that glowing streak we see is called a meteor. Makes sense, right? Most meteors are really, really tiny. So they burn up in the atmosphere. They turn to a very fine soot. But some are large enough and dense enough to actually make it through the atmosphere, traveling at many thousands of miles an hour, and land on the ground. And then they become meteorites. And there's a final term called a meteorong, which is something that looks like a meteorite, but which actually isn't. So we have meteoroids in space, meteors when they hit our atmosphere, and finally, if we're lucky enough and it lands on the ground, it's a meteorite. Most of the meteors that we see on any night that you pick come from comets. They are just little pieces of dust and crumbs from comets. What makes the Perseids special is that they all come from one particular comet called 109P Swift-Tuttle, or just Swift-Tuttle. So Comet Swift-Tuttle is the parent of the Perseid meteor shower. So whenever you see one of these little meteors flash next Tuesday night, you're actually seeing a piece of this comet burn up in the atmosphere. How does it get here? Well, you probably already know, especially if you've listened to a couple of the other presentations, that the comet itself is actually, it's called the nucleus, and they're just 1 to 10 kilometers across. They're generally small, and they're made of mostly ice, but the ice has got lots of dust in it. And when that comet gets closer to the sun in its orbit, the sun's heat, just like on a hot day, where you can see if you put a glass out with ice in it and the ice melts, or you spill water and the water evaporates, the sun's heat vaporizes the ice in that comet, a portion of it. That ice then releases or turns into a vapor that contains dust and gases. And that dust is blown back by sunlight to form the tail. And the material in that tail ultimately becomes meteors, provided the Earth intersects the orbit of that comet. The two cross one another. Here's a wonderful picture of a comet called 67P. Look at it, it's just shooting out these jets of gas and dust from its icy core as it's heated by the sun. There you're seeing raw material for meteors. Sometime maybe the Earth will pass through some of that in the distant future. Here's what it looks like close up, taken by the Rosetta spacecraft. Literally a blizzard of dust and small ice particles that are being lofted off the comet as the ice vaporizes. How big is this stuff? Well, a lot of it is really small. It's just dust that you could blow away. Some of it is even smaller than that, but mixed in there that tumbles away from the ice as it vaporizes are things the size of grape nuts. That's what this is a photograph of. They're kind of soggy grape nuts here, but in a comet, they're hard grape nuts. Small crumbles like that. And those crumbles can actually make quite brilliant meteors, sometimes called fireballs. How did we get the Perseids into our sky in the first place? A comet has a tail. That's the material that's blown back by the sun. That material is deposited, spread out in the orbit of the comet. All right, so the comet's orbit has got a lot of dust around it, kind of like a, I don't know, a dump truck that might lose some of its garbage as it's traveling down the road. The Earth is traveling around the sun the same way that Comet Swift-Tuttle is traveling. On August 11th and 12th, the Earth's orbit intersects with the orbit of the comet. So the two cross. The Earth actually plows right through the orbit of the comet. And guess what happens? All that dust that's circulating around its orbit strikes the Earth's atmosphere at about 133,000 miles an hour, and it burns up, and we see the meteor shower. Not just one meteor, but because there's lots of dust in there, we see meteor after meteor after meteor. We're plowing through the dust trail of this comet, and little pieces are arriving on Earth. You have done this in your car in a rainstorm or a snowstorm. When you drive in the snow at night, I managed to balance the phone here to get the right picture while keeping one hand on the steering wheel, I guess. When you drive into the snow, you will notice that the snow seems to stream from a point in the distance, and they all stream away from that point. This is exactly the same thing that happens with the radiant in the sky. The way we see meteors stream away from one point in the sky, that's because the Earth is plowing through this snowstorm of dust. And if you do a composite photo of many meteors over a couple of hours, like this person did, it looks almost the same as that previous picture of the snow. Here you can see these sparks of light and get a sense, actually, of the Earth's motion forward right into that cloud of comet dust. And that stuff strikes the atmosphere, and it hits at 133,000 miles an hour. You can imagine the heat, the friction from that incinerates the particles, the little grape nuts and the dust, and it causes the air to glow and makes meteors, what we call a meteor. Here's another view of the radiant. I put in some crazy looking meteors here. There it is right below the W of Cassiopeia. That's the radiant point. And you can see that it is, again, like that snowstorm. We're driving straight into it. And so these meteors, like snowflakes, appear to be streaming from one particular direction called the radiant. Now they look like they are all over the sky, right? If you go to look at any meteor shower, you can look anywhere in the sky and you will see meteors from that shower streaming all around. Again, if you follow their trails backwards and they point down to the radiant, you know you've got a Perseid. Those meteors are actually, or the trails I should say, are exactly like these railroad tracks. Do you see how the railroad tracks look very wide in the foreground, but they appear to converge in the distance? If we could keep going, it would almost seem like those rails would touch. Doesn't it look that way? Well, the rails do not touch. They are parallel all the way through. And as the Earth plows through that comet dust, those trails of the meteors are really parallel, just like railroad tracks. It only looks like they're streaming from a tiny spot in the sky. It's a perspective illusion, just like a railroad track. I have been asked whether Comet Neowise, which has been such a beautiful comet the past month. My gosh, it was a month of staying up way too late for me, or getting up early in the morning. Well worth it. What a magnificent object from the countryside. I was asked, well, I see dust here coming out of the tail of Comet Neowise. Will that make a meteor shower someday? And it might for another planet, but it will not for the Earth turn into a meteor shower, because for one single simple fact, the Earth's orbit and Comet Neowise's orbit do not intersect. You've got to have them cross, right, before you can get those little bits of comet dust to smack your windshield, the windshield being the atmosphere. So no, there will be no future meteor shower from Comet Neowise, at least not for planet Earth. Speaking of planet Earth, look at this view. What a perspective, right? This is from the space station. It was taken by a NASA astronaut during the Perseid Meteor shower, looking down at one of those pieces of the comet striking the atmosphere, looking down and seeing it glow as a beautiful streak. Isn't that amazing? So you can see them from above, you can see them from below. Most meteor particles, meteoroids, right, before they arrive, and then when they arrive, they're meteors. Most meteors flare up there about 60 to 70 miles over your head. So yes, from the space station that orbits 250 miles high, they get to look down, not only at meteors, but also at the northern lights. Lucky for us, the Perseids are rich in a special kind of meteor called a fireball, or fireballs. And a fireball is a meteor that's as bright as Venus or so, or brighter. They're the ones where you go, oh my God, did you see that? That kind of meteor, one of those you might see a couple times in your lifetime, a spectacular fireball. It will just really change your life. It's an amazing thing to see. Very rich in fireballs. NASA did a study of fireball rates for different meteor showers. And you can see that the Leonids they have 90 across the entire length of the shower during the recording of all the meteors. But look where the Perseids stand. They're the richest of all in fireballs, 568 in this particular shower. So be on the alert for them. Fireballs are just gorgeous to see. And also, fireballs leave something behind them that sometimes smaller meteors do not. And I bet you've already seen this fascinating phenomenon. It's called a meteor train. Have you ever been watching a meteor that goes flashing by, and then you'll see a glowing streak of light that is still there? The meteor's done, but there's this streak that just lingers for a couple of seconds, maybe a second, maybe 2 seconds, 3. That's called a train, a meteor train. And here you can see this photographer recorded the evolution of a particular meteor train from when it first appeared here on your left, as it fades, and it's still there many, many seconds later. And what it is that you're seeing is air that has become ionized, extremely excited by the passage of the meteor. It just knocks electrons off of those atoms up there. Those electrons recombine, they join their atoms again, and when they do, they give off light. And if it's a larger than normal meteor, very fast, that glowing light, that trailer train will last for several seconds or longer. Watching a meteor shower is one of my favorite things. This is me demonstrating the incredibly complicated technique of how to watch a meteor shower. You get the folding chair and you put it out in your yard and you lay back. Now, the nice thing about the Perseids is that you could do this without any heavy clothing. There's another shower that appears called the Geminids that in the month of December. And the Geminids require a lot of cold weather clothing, but you could just relax in a nice chair, maybe bring tea or coffee or hot chocolate, bring your children out so that they can enjoy the shower. It should be active enough by early in the evening, say around 10, maybe even as early as 9:30, for you to see at least a few meteors before the kids go to bed. Always share these wonderful activities. Just set up several chairs and make it a fun event. Go down to the lake, lay down on the dock, lay in the hot tub. People have come up with all great ways for looking at the shower. So just to recap, Perseids will be best Tuesday night, Wednesday morning, August 11th and 12th. This is what you should do to enjoy it the most. Find a dark place to watch. Or if you're stuck with neighbors' yard lights, you may want to use the opportunity to talk to your neighbor about that, or even invite them over for a socially distant viewing of the meteor shower. So as dark a place as you can find, the darker the sky, the better, right? Because you're going to see more fainter meteors. Relax, look up. It's the easiest thing to do in astronomy. And you can face any direction you like. I sort of like to face off to the east-southeast, so I have the radiant off to one side. Then I can see the little shorty meteors near the radiant, and then catch some of the longer ones that are further away. Start around 10 o'clock, but know this, the later you stay up, the higher the radiant rises, and the fewer meteors are cut off by the horizon. As a result, you will see more meteors the later and later and later you stay up, because the radiant and the constellation Perseus get higher and higher and higher in the northeastern sky. So stay up late if you can. Some people go to bed early and then they get up at 2 o'clock in the morning. One small factor affecting morning viewing for this Perseid meteor shower is that the moon will be about half when the meteors are at their best. So there'll be some light, some distraction from the moon, but it shouldn't damage the shower too much. I would expect to see 40 to 60 meteors per hour on average from a typical observing place. While you're out, this is one of the best things about meteor showers, besides the shower itself and that wonderful sense of anticipation. You can enjoy the other things that are up in the sky at the time, which include the Milky Way, if you happen to be in a dark place. But the planets Jupiter and Saturn are out there right now looking just gorgeous. 2 bright spots of light in the southeastern sky. Can't be missed. Jupiter is the brighter of the two. So I'd encourage you to swing around to give a look at them too. And I'm going to come back to you now. And one of the things that I really like, I've talked about the anticipation of a meteor, waiting to see it. And sometimes I will set like a goal. It's like, okay, I'm going to stay out until I see 20. And then inevitably after I see 20, then I think, well, maybe just one more. How long could it take? And then you wait. And the next 2 minutes seems like an eternity. And then all of a sudden you see 2 more. And then you feel like staying longer. Before you're done, you might see 70 or 80 or even 100 meteors. It's just such a unique and enjoyable astronomical experience. And that's the Perseid meteor shower. Set your phone or mark your calendar for August 11th, the morning of the 12th. If it happens to be cloudy, and that sometimes happens, you'll get the peak night be overcast. You can go out the night before and you will definitely see Perseids, about half the number roughly, and the night after. Matter of fact, that whole week, you will see at least a few pieces of Comet Swift-Tuttle shooting through the sky. So with that, I leave it open in case you have any questions about meteors and comets, or anything else you might be interested in about the night sky. I'd be very happy to answer your questions while I have a sip of tea.
Questions or comments, please type them in the comment section here in Zoom or in Facebook. And we do have one comment that a viewer says that this was exciting. They saw the meteor shower in Hawaii one year and it was breathtaking.
Yes, it is. I bet it was wonderful from Hawaii because you can find dark skies really easy on the islands. And the radiant is up there too. It's nice and high, late at night. It's definitely worthwhile to watch. Be aware that a lot of the meteors will be, the majority, I would say, are medium bright to faint. You know, in nature, there are more small things than there are big things usually. But you will see throughout, now and again, an occasional fireball or really bright meteor. And sometimes you'll see color too on the brightest meteors. They often look a little bit green from excited oxygen, or sometimes even material that the meteor is made out of, like iron and nickel, or silicates, things like that. So yes, Hawaii would be a great place, but just about any fairly dark place will do.
We have a question asking, where have you viewed the meteor shower?
Where will I see it? I'm a little bit lazy and it's reasonably dark here. I could drive easily 10 miles north where it's darker, but you know, I just like cracking open the lawn chair right in the driveway. So I'll watch the meteor shower from my house with my daughter. I'll invite her out. She's a late night owl too, so I know that the two of us will have a good time out there talking. It's a great way to talk almost spiritually too with someone when you're out under the night sky. It comes easy, and so a meteor shower is a great excuse to sort of open up in that way when you're outside at night. So yes, at home with my daughter.
Okay, another question. Somebody would like to know what time is the peak time on the 11th to 12th. What time would be the peak time to watch?
Well, the peak time would be in the early morning hours. I would say probably around 2, 3, 3:30, right in there. But you will have a moon, which will take away the fainter meteors. So what I'm going to do is I'm going to start watching, well, I'll probably start watching at around 10:30, and then I'll stay up until after moonrise, until probably 12:30, 1 a.m. The moon will rise around 12:30. So I'll just stay out a couple of hours and enjoy the show, getting something to eat, snacking in between, of course. But the actual peak time would be in the early morning hours of the 12th, but it will be compromised by that moon a little bit. Good question. Thank you for asking.
And that looks like that we're at the end of the questions. So would you like to say anything about the next presentation that will be on the August 18th?
I would. And it's something that our viewers, our sky watchers can look at in the coming couple of weeks. And the next topic will be on the planet Mars. Because I've noticed that Mars is now up. When I'm getting ready to go to bed, I'll look in the eastern sky and I'll see this bright reddish light there. And you'll see it too, perhaps on the night of the Perseids. Planet Mars is coming back into the evening sky, and it's going to pass close to the Earth this fall. So we're going to do a little preview during the next presentation about Mars and what to anticipate.
All right, and then before we wrap up, or as we wrap up, just again to remind you that if you'd like to look at Astro Bob's blog, you can go to astrobob.areavoices.com. And if you'd like to see more about the dark, oh, I lost it there. Hang on. Sorry about that, everyone. If you'd like to find out more about Voyagers National Park Association, you can go to voyagers.org, and if you go to that dark sky page, have a recording of this session as well as all of the previous sessions. Look forward to seeing you, and thank you, Astro Bob.
Thank you very much.